Good day, I'm Cora Johnson, and these are my colleagues Reid and Victoria Klaus. Today we are presenting ongoing class research on secondary succession and Point Pleasant Park following Hurricane Juan. Our study is being conducted in Untakoy, a traditional gathering place of the Mi'kmaq community, meaning a place of the spirits. This area is part of an unceded and treaty territory of the Mi'kmaq people. We are all treaty peoples. Point Pleasant Park is 75 hectares of land full of life and diverse in tree populations. Located in Halifax, Nova Scotia, this former British defensive base is between the Northwest Arm and the Halifax Harbour, and as such has a variety of ecosystems on the premises. As of a study in 1985, Point Pleasant Park consists of 80% soft-standing trees, which are red spruce and white pine. This forest was considered over-mature as almost half of the trees were over 86 years old at the time and had little growth under the canopy layer. To compensate for previous deforestation in the surrounding areas, new species of trees like the red maple were introduced to Point Pleasant Park. As of 2008, there were over 35 kilometers of trails within the park and over 1.5 million visitors each year, making Point Pleasant Park a staple in the community. 2 decades ago, Hurricane Juan made landfall in September 29, 2003, in Halifax, significantly impacting Point Pleasant Park. This Category 2 hurricane had winds up to 145 kilometers an hour and created widespread damages in tree populations. Because of Hurricane Juan, Point Pleasant Park lost 85% of tree population. Over the past 2 decades, surveys have been conducted observing the tree populations following this hurricane. A plant, in this case trees, recolonization of habitat after a major disturbance, in this case a hurricane, is called secondary succession and is what the study aims to observe. Turchin observed the overall abundance of trees in Point Pleasant Park increased by 40-fold 9 years after the hurricane. We aim to determine how and why secondary succession is occurring in Point Pleasant Park by studying the changes in the forest community over time using data collected at the 6 sites located in the most impacted areas of the park.
So our first research question is, how has the overall forest community changed over time? Our second is, how has the density of the dominant species in 2004 as well as the dominant species in 2023 changed over time? And our third is, how has the chosen community metric changed over time? We're also going to look at how these influence the overall forest community as it moves towards its climax community. So we have 3 hypotheses. Our first one is that the total species density will increase following Hurricane Juan in 2004, creating increased crowding in the overall forest community as it moves towards climax community. Our second is that the ratio of red spruce and maple will stay constant. And our third is that over time, species richness will increase as the forest community continues to recover from the loss of biodiversity.
Point Pleasant Park's forest is located on the south end of the Halifax Peninsula. It was once the site of an even-aged old-growth forest. However, with the high wind speeds produced by Hurricane Juan, over 70% of the forest canopy was uprooted and damaged. Shown in Figure 1 are the 6 study sites selected during a survey of the park's forest. These specific sites were chosen based on the severity of inflicted damage, with the total area of each site being 400 meters squared. The study began in 2004 and continues to run to present day. There is an exemption of some years from this study due to the presence of other hurricanes, therefore no data was recorded. Data recorded at each study site includes tree density, which is the number of trees belonging to each species, as well as tree size. To measure tree size, the technique of diameter breast height was used. It is a standard unit of measure practiced by the logging industry. Data collected from tree density and diameter breast height can be processed and displayed on graphs in the form of species richness and red spruce density, red maple density, and total density. Though linear regression equations, the strength of these relationships are evaluated and can be further analyzed to determine the estimated effect Hurricane Juan had on Point Pleasant Park's forest community.
After Hurricane Juan, the total density of tree species in Point Pleasant Park increased 34-fold between 2004 and 2023. Figure 2 represents this. There is a basic linear increase after the hurricane based on the steep increasing regression slope. There's an average increase of around 10 new species per area per year up until 2015. After 2015, total density then seems to plateau out, suggesting that the population reached its climax community post-2015, a condition of this being the data's greater variability. This data suggests that while variable, under the same environmental conditions, future total density will remain at its apparent climax community, which is congruent with Turkin. This is an example of environmental stochasticity and the influence extreme weather events have on community populations. Given Figure 2, with the increase followed by the decrease in total density up into 2015, this could suggest that species crowding may have been a driver of the local density decrease.
Following Hurricane Juan, red spruce populations, as seen in Figure 3a, were low with a steady increase by threefold between 2004 and 2023. Red maple, on the other hand, as seen in Figure 3b, experienced a 36-fold increase between 2004 and 2023, becoming the dominant species. This differs from the hypothesis that red spruce and red maple densities would stay consistent. Additionally, this also differs from tree populations prior to the hurricane, as Point Pleasant Park was once dominated by red spruce and other soft-standing trees. This difference in dominance and density is likely due to the growth rate difference between the two species. Red spruce has a longer growth rate and persists for 350 to 450 years, whereas red maple only persists for 150 years. This conclusion is congruent with Turchin's work, as red maple increases 38-fold and red spruce increased 1.5-fold from 2006 to 2025 in Point Pleasant Park. As the forest moves toward the climax community, the red maple is likely to stay the dominant species. However, it is likely for other species, like the red spruce, to have a higher ratio in the overall density of the forest. As seen in Figure 3b and Turchin's research, there is a strong peak in the red maple's density, changing from a 48-fold increase between 2006 and 2015 to a 36-fold increase between 2004 and 2023. This is paired with the red spruce densities increasing by 1.5-fold to 3-fold over the same time. Overall, this would support the red spruce would increase in the density ratio, which contrasts the hypothesis that the ratio between red maple and red spruce would remain the same. This is likely due to the persistence period in the red spruce being longer than the persistent period of the red maple.
Figure 4 illustrates how species richness has increased during the study. Using linear regression, the overall link between species richness and time was examined. The results produced a p-value of less than 0.05 and an r-squared value of 0.64. According to these statistics, there is a strong positive correlation between this measurement of diversity with respect to time. Furthermore, the increase of species richness following a disturbance, displayed by the dotted trendline in Figure 4, aligns with the successional theory that states an establishing community will take advantage of new resources. Based on this evidence, I can predict that species richness in Point Pleasant Park will continue to increase, moving towards its climax community. In addition, Figure 5 is a proposed model of forest ecosystem recovery following a disturbance. Focusing on Phase 2 labeled aggregation, there is a significant increase in biomass during this phase of recovery. Comparing the dotted line in Figure 4 to the slope of the line in Figure 5, there's obvious similarities which could place Point Pleasant Park's recovery somewhere in Phase 2. As well, an increase in the abundance of trees in Point Pleasant Park is equivalent to an increase in biomass. Therefore, I can conclude that an increase in species richness signifies a more diverse environment. Pairing that with the changes in Point Pleasant Park's forest community being consistent with trends described in successional theory, this evidence indicates that the forest moving towards its climax community is also in a simultaneous recovery.
The results of this study suggest that the Acadian forest in Point Pleasant Park experienced secondary successional trajectories after catastrophic disturbance and is currently experiencing late succession. Total density took about 14 years to reach the climax community after a major environmental event. Red maple is the dominant species compared to red spruce. The growth rate of red maple has slightly decreased, whereas red spruce is steadily increasing. And it was also found that species richness has a strong positive correlation with biomass. Urban parks can face additional challenges regarding succession. For example, many urban parks contain non-native species like the red maple in Point Pleasant Park. As seen in the question 2 results, the introduced red maple influenced secondary succession with competition, a challenge many urban parks faced post-disturbance. Also, since this park is a staple of the community and is used for daily nature walks and dog walking, there are many disturbances that could affect the ecosystem. If organisms such as squirrels and birds are fed by humans in these urban parks, there likely would be a reduction in seed dispersal in the forest community. One indigenous practice that can be applied to this study is the seventh generation principle, which is the idea about how the decisions being made today will affect future generations and is mainly in reference to the land's health. The general idea is that making environmentally friendly decisions now will ensure a sustainable environment in future generations. This further drives home the importance of the conservation of these community green spaces.
We want to express our thanks to the fall students who went into the field and collected the data each year for the study, as well as Christine Bowenkamp for initiating this research project. We also appreciate the work done by Allison Schmidt, who made the graphs and calculated the statistics used throughout the presentation. And additionally, we want to thank the Mi'kmaq people for the use of their traditional and ancestral territory.